Swayam Prabha. Digital India. Educated India.
So, welcome to the lecture 5 of time series modeling and forecasting. In this lecture, I will focus on different components of time series, particularly the seasonal and cyclical plots. As you remember, in the last lecture, we have considered the methods, different methods for the determination of a trend component. In particular, we have considered the method of mathematical curve fitting and the method of moving averages. Now, here we will consider different plots for the seasonal component, and then we will also consider the methods for the determination of seasonal component. Now, seasonal variation is a regular periodic variation with period of cycle within 1 year. Usually, the period of cycle is it depends upon the season, whether it may be 1 month or it may be 1 quarter, but it is within 1 year. Then seasonal patterns are usually predictable. Factors recurring more or less regularly at a particular time point of the year or the week or the month are responsible for such variation. Now, those factors may be the cycles of seasons, like rainy season or winter season, holidays like summer breaks, or those reasons may be different festival seasons, or it may be caused by regular changes in behavior. We will discuss some examples also for biological. One of the possible reasons may be the biological rhythm and physiology in response to periodic changes in the environment. So, there are several possibilities, several possible factors which may be responsible for seasonal variations. Here are many examples. Say animal migration or hibernation. Now, this is an example of seasonal variations. Now, this is caused by the biological rhythm. Increase in sales of departmental stores during first week of the month. So, usually the salaried class gets salary on the first of each month. So, they go for shopping in the first week of month. So, there is an increase in the sales of departmental stores. Increase in sale of coffee and warm clothes, woolen products during winters. Now, here the cause of presence of seasonality is the winter season. The sale of coffee or warm clothes increases during the winter season. Increase in sales of fans, air conditioners, cold drinks and ice creams during summers. Again, the cause of seasonality in the sale of say air conditioners or in the sale of ice creams is your usual season. During summers, people prefer to buy air conditioners because the weather is hot, or they prefer to eat ice cream. Clothes and firecrackers are in greater demand during Deepavali period. So, during Deepavali festival period, demand for these two things increases. One expects increase in unemployment in June as recent graduates are arriving into the job market. So, this is a natural phenomenon. Each year during the month of June, you find new graduates arriving in the job market. So, there is an increase in the unemployment. Then increase in sales of motor vehicles during Navratri Deepavali period. People prefer to buy new things like cars or two-wheelers during Navratri or Deepavali period. So, again the reason is these festivals, and we get seasonal variations in the sales of motor vehicles. Increase in viral fever cases during season change period. Again you observe seasonal phenomena in the number of cases of viral fever during change of season. Then identifying and measuring seasonal variations helps you in many ways. It helps you in better planning for temporary increase or decrease in labor requirements, inventory, training, periodic maintenance, supply chain management, etc. So, suppose you observe that there is an increase in sale of ice creams during summers, and there is a decrease in sales of ice creams during winters. So, during winters you can reduce the production, and then your factory gets a chance for maintenance. You can go for repairing of machines which develop some fault, or so for maintenance purpose you can use that period. And during summer you can employ more people, so that you can increase the production, and then you can fulfill the demand, increasing demand of the market. So, in this way you can plan the things in a better way. Then eliminating it from the time series for studying other components such as trends, cyclical and irregular. So, for studying other components like trend or cyclical components, you also require to eliminate the seasonal component from the time series. Then forecasting future seasonal patterns such as climate normals. Climate normal is actually a 30-year average of a weather variable for a given time of year. So, for any particular year you calculate the past 30 years average of a weather variable. That weather variable may be the temperature or rainfall, etc. So, this also has seasonal variation, and so you can if you are taking care of the seasonal variations, then you can better forecast the future seasonal patterns. Now, first we consider different graphical techniques for visualizing and detecting seasonality. Before going to main mathematical methods for obtaining the seasonal indices, first we consider different graphical techniques. Now, some of the important graphical techniques are simple time series or run sequence plot, then seasonal plot, seasonal sub-series plot, multiple box plots, autocorrelation or correlogram and spectral plot. The last two plots, autocorrelation plot and correlogram and spectral plot, I am not going to consider here. These two plots I will discuss later on in some other lectures. Now, first we consider the simple time series or run sequence plot. Simple time series or run sequence plot helps in identifying the seasonal variations. Measure of central tendency such as mean or median may be indicated by a horizontal reference line. I think I have already shown you this graph earlier in one of the earlier lectures also. So, in the middle we are having a straight line which shows the mean, and around the mean you can observe a periodic pattern, and this periodic pattern is because of seasonal variations. So, just by looking at the run sequence plot, you can easily observe the seasonal pattern present in the average daily gas flows data. So, such kind of run sequence plot helps you in identifying the seasonality present in the time series. It also helps you any shifts in location of seasonal pattern. Sometimes it may happen. There might be a shift in the seasonal pattern. It may be shifting from June to July. So, you can identify such kind of shifts using run sequence plot. Any shifts in variation of seasonal pattern. So, apart from location, there might be some shifts in variation. Means the values in June, they are gradually increasing. So, there might be shifts in variation of the seasonal pattern. Then presence of any outlier. So, usually the demand of ice cream increases during summers, but in a particular year you observe that the demand has not increased. Then you must look at the reason why this kind of outlier you have obtained. Just for example, say in 2020, because of this COVID problem, people avoided eating ice cream during even in summers. So, demand for ice cream decreased. So, that particular observation is an outlier. So, any such outliers can be easily detected using the run sequence plot. Next plot is seasonal plot. In seasonal plot, the time series observations are plotted against the individual seasons in which the data were observed. So, let us consider this example of average daily gas flows data. We have 4 years data. Series 1 denotes the graph corresponding to year 2008, series 2 denotes the graph corresponding to year 2009, series 3 is corresponding to 2010 and series 4 is corresponding to 2011. Now, on the x axis we have taken different months, and then we have plotted observations corresponding to different years against different months. So, this blue graph is for the year 2008. This orange graph is for the year 2009. This gray graph is for the year 2010, and the last one, this black one, is for the year 2011. Now, just by looking at these graphs, you can easily visualize the seasonal pattern. You observe that for all the years, the observations have a increasing pattern. The observations are going to increase during the months of July, August. In January and December, the observations have a tendency to decrease. So, you can clearly visualize the seasonal pattern just by looking at the seasonal plot. You can also identify the years in which pattern changes. Say, suppose here for some other year, maybe for 2012 or 2013, you get a graph like this. So, you can identify the change in seasonal pattern. So, then you can look for the reason behind such kind of change. You can also observe which of the year has more or larger observation during which month. Say, in January, which year has the largest observation? This series 3 observation means the year 2010. So, this kind of inferences you can easily draw using seasonal plot. Now, here is the airlines passenger data, which is available in the software R. So, I am showing this data set because for future graphs I am going to use it. Then we have plotted this data set using seasonal plot. So, again different years are shown using different colors. On the x axis, we have taken different months, and on the y axis, the values of the time series. Now, this graph is for the year 1949. The second graph, this one, is for the year 1950, and so on. And the last one is for the year 1960. You can easily identify the seasonal pattern in the data using this graph. Not only that, you also observe that over the years, the number of passengers is usually increasing. Say, you take any particular month, say you take the month of August, and then you observe that the number of passengers traveling by air is increasing with years. So, not only the seasonality is present, but trend is also present in this data set. Earlier I also showed you the simple time series plot of this data set, and in that plot also we observed the increasing trend. So, this is how seasonal plot helps you in identifying the seasonal patterns or the months in which the observations have a tendency to increase. Also, the months in which the observations have a tendency to decrease. Not only that, you also observe that the number of passengers traveling in January is quite close to the number of passengers traveling in December, or number of passengers traveling in November is quite close to the number of passengers traveling in February. So, this kind of inferences you can easily draw using this plot. Then seasonal polar plot. In seasonal polar plot, we start from the first observation. Say we have started from the year 1949. Here also we are plotting that airlines air passengers data set on the polar plot. So, we started from the year 1949, we plotted the observations corresponding to different months, but now you have taken different months on this circle. So, January, February, March, April and so on, you go up to December. So, you start from here, then you move ahead, and ultimately you join all the points using a straight line or a smooth curve. So, actually this polar plot also gives the same information or similar kind of information as the seasonal plot, but it becomes easier for you to make comparisons. Means here also you easily identify that with the passage of time, not only seasonality is present in the time series, but increasing trend is also present. So, means one more thing you observe that whenever the year changes, we have changed the color of the graph. So, that you can easily identify the observations corresponding to different years. So, just by looking at this graph, you can draw this kind of inferences. Say November tends to have very low values. So, look at the graph corresponding to November, these November figures. So, these November figures tend to be very low, while August and July have higher values. These are the figures corresponding to July and the figures corresponding to August. So, August and July have higher values. But it becomes difficult for you to visualize if relative values hold across months in the inner layer, because in comparison to the outer layer, this inner layer is very small. So, means it if there is a big difference between outer layer and inner layer, and if inner layer is quite small in comparison to the outer layer, then it becomes difficult for you to visualize if the relative values also hold for the inner layer. Means whether for the inner layer also August and July values or not, or whether for inner layer also November has lower value or not. Sometimes it becomes difficult for you to visualize it. Now, this is seasonal subsidies plot. Again, on the x axis we have time of years, months or quarters, etc. One thing you must remember, for all these graphs, you must know the period of seasonality, whether it is monthly seasonality or quarterly seasonality, etc. So, on the x axis, suppose the data has is monthly data and you have some kind of monthly seasonality. So, on the x axis we have taken different months, and corresponding to different months you have plotted observations of different years. Means in air passengers data, we have started from 1949, then we went up to 1960. So, this is the plot of time series for the month of January from 1949 to 1960. The second graph is the plot of observations for the same years 1949 to 1960 for the month of February. Third one is for the month of March, and so on. Then this blue line, blue horizontal line, gives the mean graph, and this mean graph makes the evolution over time clearer. This is the mean of observations for the first time series, for the time series of January. This is the mean of time series for February, and so on. Now, just by looking at these means, you can easily visualize the pattern of seasonality. Means from here to here, you observe periodicity. But visualization of between season dynamics is a difficult, but that is whether they persist or not. Now, this is a problem with this graph. So, we cannot tell that November always has less number of passengers than December. Say in general, the mean of November graph is less than that of December graph, but you cannot say that November always has less number of passengers than December. This is also a seasonal subsidies plot for CO2 data. Again, if the period of the seasonality is known, we may use this plot for detecting seasonality in a time series. But if period of seasonality is unknown, then you can check the period of seasonality by using the correlogram, which we will discuss later on. So, again here also in this example we have plotted the time series for each month or season. So, for January this is the graph, for February this is the graph, and then we have plotted some measure of central tendency. Generally we take the average value, or sometimes we also take the median value and plot that value as a straight line. So, if the period is not known, an autocorrelation plot or the spectral plot can be used to determine it. Well, later on in some lecture I am going to cover these two plots also, autocorrelation plot or the spectral plot. Then using seasonal subseries plot, we may analyze that whether data exhibit a seasonal pattern or not, just by looking at the graph or by looking at the center values like mean or median. You can up to some extent identify whether the seasonality is quarterly or whether the seasonality is annual or monthly, etc. But take care, for observing that whether the seasonality is quarterly or not, you must have either quarterly observations or monthly observations or weekly observations or daily observations. So, if you are taking annual observations, you cannot identify quarterly seasonality, or if you are taking quarterly observations, then you cannot identify monthly seasonality or weekly seasonality. If seasonality within a month is present, say there is more sale in a departmental store in the first week of each month, but you have quarterly data of sales, then you cannot identify that weekly seasonality or monthly seasonality. Any within group pattern, for example, do January and July exhibit similar patterns? This also you can identify using the seasonal subseries plot. This is the graph for January and this is the graph for July. Whether these two graphs have similar pattern or not, you can easily see. These two graphs have don't have similar pattern. Although the medians are quite, or mean values are quite close to each other, but still the pattern is different. Presence of any outliers after taking seasonality into account. This also you can easily identify. If there is any outlier present, then you can identify that outlier. Whether seasonality pattern is changing over time, this also you can check. With the passage of time, whether seasonality is changing or not. Now, sometimes you have very high frequency data. High frequency data means you have very large time series and the observations are taken at very short interval. Now, if you try to plot those observations using seasonal subseries plots, then you may not be able to get very clear picture, because in the graph you will have a lot of observations plotted on the similar graph. So, you will not be able to identify whether there is some seasonal pattern or not, or the behavior of the seasonal pattern, etc. In that case, we use multiple box plots. So, instead of considering the entire time series, or instead of plotting the entire time series for a month or for a quarter, we just consider the box plot for that particular month or for that particular quarter. Now, first I define what is a box plot. A box plot can be constructed by considering 5 elements. You need 5 quantities: the upper and lower quartiles. Then you also need median value. Then data which lie exactly 1.5 times the interquartile range, and outliers which lie outside the 1.5 times the interquartile range. Now, here is an example of box plot. So, this is the median. Then upper and lower quartiles are given here, and using these 2 quartiles you can also obtain the interquartile range of the data. Then these lines, these two lines show the 1.5 times the interquartile range. And any observations outside this region are your outliers. So, you have 2 outliers, this one and this one. So, box plot gives you this much of information. For plotting box plot, you need these quantities: median, upper and lower quartiles, and then you can easily obtain the interquartile range also. And you only plot those points which are outside or 1.5 times outside the interquartile range. Means you are plotting only those points which are outliers. Information about other points are contained in this box plot. Okay, now we consider multiple box plot. So, this multiple box plot provides you an alternative to seasonal sub-series plot for high frequency data. Because with high frequency data, the picture with the seasonal sub-series plot may not be very clear. So, we prefer box plot. Every box plot data is considered on a specific temporal interval, say day, week, month or quarter. Here we have monthly data. We have used the same air passengers data. Then box plot time series also displays intertemporal variations. Means now this is the box plot corresponding to January. So, for the month of January, this is the plot for all the years. So, in January, how much variation is there? This interquartile range provides you a measure of variation for the month of January. Similarly, for the month of February, this interquartile range provides a measure of variation, and so on. In the middle, you plot median. Then these two lines are 1.5 times the interquartile range, where here we do not have any outliers. So, no outliers are displayed here, but suppose you have some outlying observation for the 4th month, means April, and that observation is here. So, we plot that observation here. Or suppose you have another outlier for the 7th month, means July. So, we plot that observation here. Okay. Now, just by looking at the box plot, you also observe the seasonal pattern. So, you observe periodicity. And this is the box plot of monthly time series of San Martino, Italy rainfall data. So, this is the plot of run sequence plot of rainfall data. This plot is also showing the seasonality, but the picture is not very clear. But once you use the multiple box plot, the picture becomes more clear. So, again each box plot has the same information. So, it gives you the median value, it gives you interquartile range for the observations of each month, and if there are any outliers, then you have to show those outliers on the graph, etc. Next, we come to the cyclic variations. The cyclical variations are gradual, relatively long term, and up and down, potentially irregular, repetitive movements of the time series. In cyclical movements or in cyclical variations, the period of cycle is usually more than 1 year, whereas in seasonal variations it is usually less than 1 year. A cycle occurs when the data exhibit rises and falls that may not be of a fixed frequency. Usually in seasonal variations, the frequency does not vary much, but in cyclical variations this frequency varies, it is not fixed. The period usually extends beyond a single year. This point I have already mentioned. The period of cycle is usually more than 1 year. Then cyclical variations is periodic in nature with 6 phases. Those 6 phases are expansion, peak, recession, depression, trough, and recovery. Now, using this graph, I can show you those 6 phases. Now, this is the period of expansion, where the time series is increasing. Then it reaches its peak. Then it starts decreasing. So, this is the period of recession, and then it goes below this middle value. So, this is the period of depression. Then ultimately it reaches at its minimum trough. Then again it starts recovering. So, things start increasing, and after reaching this normal value, it starts expansion period starts. So, again it reaches peak and then you get recession, etc. So, these are the 6 phases of business cycle. In every business you observe this kind of cyclical variation. You observe expansion period, then it reaches its peak, then you observe recession period, depression period, reaches its minimum trough period, then again it starts recovering. So, these are the examples of periodic variations. Say business cycle, economic expansion are followed by economic recession, followed again by economic expansions, etc. These expansions and recessions differ in length. So, it is not exact periodicity. These differ in length. Price cycles. In prices also you observe cyclical pattern. Occur when future production decisions are based on current prices and producers have little control over the prices. For instance, industries involving large number of relatively small operations, and then you observe some kind of cyclical pattern. Solar cycles, cycle that sun's magnetic field goes through approximately every 11 years. This is a very popular example of periodic variation. Actually, sun's north and south poles switch places in 11 years. So, the entire magnetic field of sun completely flips in 11 years, and that activity of sun affects the sunspot data. So, here I have plotted sunspot data of the solar surface. The site from where I have downloaded the data is given here. This is the site. Royal Observatory of Belgium site I have chosen for downloading the data. Then I have plotted daily data, monthly data, both. This yellow graph shows the daily data, and this blue one gives the monthly data. Then this orange one gives you the monthly smoothed data. This graph clearly shows the periodicity. This is 13 years data, but it shows periodicity. It starts increasing from here, reaches its peak and then starts decreasing. Again it has started increasing. Now, if you observe such kind of periodicity, then this kind of periodicity also helps you in prediction. Now, using this kind of periodicity, you can predict the future pattern of the data. How to distinguish between seasonal and cyclic fluctuations? Now, this is a big problem, because both the fluctuations are periodic in nature. So, on the graph, both the variations look almost alike. So, for distinguishing between seasonal and cyclic fluctuations, if the fluctuations are not of a fixed frequency, then they are cyclic. This is one indication. Then, if the frequency is unchanging and associated with some aspect of the calendar, then the pattern is seasonal. Means sale of umbrella, it is connected with the calendar. During rainy season, it increases the length of a seasonal pattern. Usually cyclical patterns have a period more than 1 year. So, the magnitudes of cycles tend to be more variable than the magnitudes of seasonal pattern. This is also one of the indications. So, in today's lecture, I have covered how different graphs help you in identifying the seasonal pattern. You can use all these graphs. Before going to calculate the seasonal indices using some particular method, which I am going to cover in my next lecture, you must look at the graph first, whether seasonality is actually present or not. And then those graphs also show you if there are any outliers, if there are any changes in the seasonal pattern. So, for preliminary analysis of the data or preliminary study of the seasonal variations present in the data, you must use all these graphs. Secondly, it is important for you to identify the difference between seasonal pattern and cyclical pattern. Do not confuse cyclical pattern with seasonal pattern or seasonal pattern with cyclical pattern. For once you identify that your time series has seasonality, then you can go for more deeper study. You can go for calculating the seasonal indices, and the methods for the calculating different methods for calculating seasonal indices will be the focus of my next lecture. So, in the next lecture I will cover all the methods for calculating seasonal indices. That is it. Thank you.
Hello, good morning everybody. I am Raghunandan Sengupta. So, I will just give you a very brief excitement area of finance, which is quantitative finance, and that has a huge market starting around about 10 years back, and it is exploding exponentially. So, what do we mean by quantitative finance? Quantitative finance is actually the application of different mathematical and statistical techniques in the area of financial markets, be it say for example derivative pricing, be it in the area of say for example portfolio management, be it in the area of asset liability management, be it in the area of portfolio management. We see that the application has exploded in such a way that there is a huge opportunity for people who have a quantitative background in mathematics and statistics. They can utilize those in the area of finance, but obviously with some prior knowledge of finance as a subject. Now, when we say about quantitative finance, as I said, it is an area of applied mathematics and statistics applied in financial markets. Use of different areas, if somebody is interested to know, we have stochastic calculus, we have derivative pricing, we have operation research, we have quantitative techniques like differential equations, stochastic calculus, time series, and they are heavily used in the area of quantitative finance as I mentioned. Now, we all know that in 1997 the Nobel Prize in Economics, so it is basically the Nobel Memorial Prize in Economics was given to the work of Merton and Scholz in the area of derivative pricing, and after that there has been exponential increase in the area of quantitative techniques in quantitative finance and in the area of different type of derivative pricing. With the advent, moreover with the advent of high-ended and sophisticated computing data, big data has come in a very big way, where application areas starting from computing, from different type of algorithm design have been taken up in such a big way that nowadays at least we are able to understand that how high frequency data algorithm trading can be utilized using the concept of quantitative finance in the area of finance as such. But there is a flip side also, obviously when there is a huge amount of development. So, obviously due to some regulation errors or something, there has been some pitfalls, which I think should be a bullet point for people who are really interested to take up quantitative finance. They should be aware. So, consider the financial crisis in 2008 and later on, and we are seeing different banks are failing, different financial institutions are facing a problem, countries are facing a problem like in Europe, in USA. So, what should be done? So, the main thing is that even if you know the technique, is best for people who are investors, who are private players, organizations like banks, governments should use these techniques in a very somber manner, such that the application areas of quantitative finance using the techniques which we learned can be utilized in the best possible way to garner the overall the in-depth knowledge a person has in trying to utilize these quantitative techniques in finance. And I am sure that people who have the background, who have the knowledge, who have the sophistication, who have the knowledge of the society can definitely use quantitative finance in a very big way in trying to make their mark in this exciting field, which you are going to see in years to come. And I am sure it will be a very exciting learning tool for all the participants who will take quantitative finance as a subject in years to come. Thank you, and I wish all the participants all the best and best of luck for the programs they will take. Thank you.